Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 7, Mental Math. Okay, opening exercise. How are these two equations related? So this is an opening exercise. Pause the video, see if you can answer this, and then come back. So how are these two equations related? Well, we have x squared minus 1 divided by x plus 1. And it says it equals x minus 1. Well, if I multiply both sides by x plus 1, I get this over here. So I multiply both sides by x plus 1 to isolate the numerator is one way we could look at it. Or we could just simply say this. They represent the same relationship between the expressions x squared minus 1, x minus 1, and x plus 1, as long as x does not equal negative 1. Well, why do they say that? What is the significance of this? Right here. Why can x not be negative 1? Well, if x is negative 1, negative 1 plus 1 is 0, and we cannot divide by 0. It's undefined. Okay, so B, explain the relationship between the polynomial identities x squared minus 1 equals x plus 1 times x minus 1, and x squared minus a squared equals x minus a times x plus a. Okay, so in this one, the expression x squared minus 1, the expression x squared minus 1 right here, equals x plus 1 times x minus 1, the expression x squared minus 1 is in the form of x squared minus a squared, with a being 1. 1 squared is 1. Note that this works with a equals negative 1 as well. So in this case, we can have a equal to negative 1 because we are not dividing. Okay, so I just want to say a little more about that. If a equals negative 1. Well, for a to equal negative 1, we still could make this a division problem as long as we wrote this x minus a under here instead of the x plus a. So if I multiplied both sides by x minus a, this would be gone over here, it'd be under here, and x squared minus a squared over x minus a would equal x plus a. And if a was negative 1, that'd be x plus 1. So in this case, negative 1 would work. Okay, so even if we weren't doing that, if we made this negative 1, this would be x plus 1, and this would be x minus 1, if a was negative 1. And if I FOIL that, I'm going to get a plus times a negative 1 to get that negative 1 squared, and if a was negative 1, negative 1 squared is 1, so it'd be still minus 1. All righty. Okay, exercises 1 through 3. Compute the following products using the identity x squared minus a squared equals x minus a times x plus a, and show your steps. And here is an number 6 times 8. Okay, so to do this exercise here, there was a behind the scenes thing that a teacher would do in the classroom to explain how to do this. And so the first thing I would do is say, well, what is this doing? Okay, let's try this. What is 6 plus 8 divided by 2? In other words, what's the average of those two numbers, or the midpoint, if you will? And that would be 14 divided by 2, which is 7. So the number that's halfway in between these would be 7. Well, in order to get to 6, I'd have to subtract 1 from 7. And in order to get to 8, I'd have to add 1 to 7. So my x would be 7 and my a would be 1. So in order to do this, I would say, okay, 7 minus 1 times 7 plus 1. Okay, 6 times 8, right? So then once I do that, it is going to be x, this x squared minus a squared is x minus a times x plus a. So 7 squared, this would be 7 squared minus 1 squared. So this would be 49 minus 1, which is 48. And that's pretty neat, isn't it? 6 times 8 is 48. All righty. So then if I do that again over here, let's go off to the side. 11 plus 19 divided by 2 is 30 divided by 2, which is 15. Well, that's my x. So that is going to be 15 minus something times, oops, didn't leave anything for any room for that something. 15 minus something times 15 plus something. Well, to get to 11, I'd have to subtract 4 from 15, and 15 plus 4 is 19. So my x in this case is 15, and my a was 4. Hopefully you understand that. And it's just the midpoint. It's the average. You find the average to be x, and then whatever the difference or sum is, that's your a. So now that I do this, I can now say, well, that's x minus a times x plus a. So that's equal to x squared, and x is 15. So that is equal to 15 squared minus 4 squared. And 15 squared is 225. And 4 squared is 16. 225 minus 16 is 209. And there you have it. All right, page 2 gives us a couple more examples to practice just to get a hang of this. So the first thing I want to do is find the mean of these two numbers. So 23 plus 17 divided by 2 equals 23 plus 17 is 40 divided by 2, and that's 20. So my x is going to equal 20 here. And my a is going to be the difference between 20 and these two numbers. So 20 plus 3 is 23, and 20 minus 3 is 17. So there's my a. So now I can represent this as x plus a times x minus a. Okay. And now that I know that I have an x plus a, x minus a, I now know that's equal to x squared minus a squared. So x squared, 20 squared minus 3 squared. 400 minus 9, 391. So 23 times 17, and I can check this. (23 times 17 is 391. All right, so now we're going to do it one more time. So the first thing I do is take the mean of 34 plus 26 divided by 2. That's the mean. And 34 plus 20 is 54, and then add 6 more, and we're at 60 divided by 2. So our x is 30. So x is going to equal 30. And then I look at this, and well, 34 is 4 more, so a must equal 4. And then I make sure I did it correctly. 30 minus 4 is 26. So then I can write x plus a times x minus a equals x squared minus a squared. 30 squared is 900 minus 16, which would be 884. Go to my calculator. 34 times 26, enter, 884. Okay, so now it says find 2 additional factors of 2 to the 100 minus 1. There's a whole bunch of detailed information in the teacher edition that talks about factor trees and how to get different values for n. But I'm just going to approach it a simpler way. I'm going to use the power rule of exponents, and that simply means that I can take the base 2 and take any 2 factors of 100, such as 2 times 50. And this rule says that the power of the powers you multiply. So 2 to the 100 would equal 2 to the 2 to the 50, because 50 times 2 is 100. So if I do this, 2 to the 2nd to the 50th minus 1. So 2 to the 100 minus 1. I need to write that, by the way. Let me just make some room here. I should have a minus 1 equals, because 2 to the 100 is 2 squared times to the 50, and minus 1 just goes along for the ride, and there it is. So 2 to the 100 minus 1 equals 2 squared to the 50th minus 1. So now I can just say, well, 2 squared is 4 to the 50th minus 1 is equal to this. So then we have to discuss something here for the next step. Okay, so at this point, it's impossible. It is possible to introduce the power of algebra over a calculator rather than just going to a calculator and pushing buttons. No one learns anything. You just get an answer, and what good is that? The identity x squared minus a squared is just the n minus 2 case of this identity here, where it's x to the n minus a to the n equals x minus a times x to the n minus 1 plus ax to the n minus 2 plus a squared x to the n minus 2, and so on, and so on, and so on, all the way out to a to the n minus 1. So how might we use this general identity to quickly count mentally? Well, if we have 44 to the 50th minus 1, our x is 4, okay, so our x is 4. Right here, we're using this. So our x is 4, and our a is 1. So x to the 50, n is 50, e minus a, which is 1 to the 50th, is still going to be just 4 minus 1. Okay, times, this is my x minus a here, by the way. So 2 to the 100 minus 1 is going to be the same as 4 to the 50 minus 1. And therefore, x is 4 and a is 1. That's what I'm trying to say here. And n is 50. So then it's going to be times my x, which is 4, to the power of n minus 1, which would be 49, plus a is 1 here, so it's just 1 times x, and x is 4, to the n minus 2, which would be 48, plus a is still 1 squared is still 1, times 4 to the n minus 2, which would be 50 minus 2, which is 48. Wait, I lost track here. X, 4, n minus 1, 49, plus a is 1, x to the n minus 2 is 48, plus a squared, which is still 1 squared is 1, and then x 4 to the n minus 2, which is 48. Okay, but at this point, let's just do this. Let's just do my ... plus, and then all the way out at the end, a, which is 1 to the 50 minus 1, which is 49. Well, 1 to the 49 is still just 1. Okay. So since we get this, we know that 4 minus 1 is a factor. So we have 3 is a factor. Okay. And I'm going to check that. So if I take 2 to the 100 minus 1, I get a really, really, really big number. Okay, move this decimal 30 places to the right. And if I divide this by 3, it would go in evenly. It's hard to tell with this calculator, but 3 would be a factor of that number. All right. I would need to know all the digits to see if it's divisible by 3 by adding up every digit. But then, so we just found if one of the factors is 3. So we're going to do this again. Well, how else can I represent this? Well, how about we just switch these? So now I can say 2 to the 100 minus 1 equals 2 to the 50th power squared, because 50 squared is 100, okay, minus 1. So now my x is 2. Okay, my x is 2. And that's going to be to the, oh, I'm sorry, that number is way too big. Actually, no, it's not. Let's do this. So my x is 2 and my a is 1. So this would be 2 minus 1 times x to the power of 2, x squared. Actually, I don't want to put the x. What is my x? My x is 2. So that'd be 2 squared. So let me think about this a minute. 2 squared. My outside number is 2 to the, okay, so x is 2 to the n minus 1 isn't squared. It is, my x is 2, n minus 1. Well, my n in this case is 2. 2 minus 1 is 1. So that's just going to be simply 2 plus a, which is 1, times x, which is 2. So 1 times 2 is 2, to the n minus 2. 2 minus 2 is 0. So that'd just be to the 0. So this would end up being 1. All the way out to a, which is 1 to the 1, or simply 1. Okay? And that's what that comes out to be. There should be some dots in between there, but anyhow, you get the idea. So then in this case, all that's telling us is that 1 is a factor. So that really wasn't a good example. Everybody knows 1's a factor of everything. So let's just get rid of this and let's try a different one. Try to stay away from something that only comes out to be 1. So how about this? 2 to the 5th power times 20. Okay, 5 times 20 is 100. So 2 to the 100 minus 1 is going to equal 2 to the 50 to the 20th minus 1. Let me just change the colors on this. Okay, so this is now going to equal, I change it to blue so it's not the same as color as this right here. So 2 to the 100 minus 1 is now going to equal 2 to the 5th is 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So 2 to the 5th is 32. So now I can represent this as 32 to the 20th minus 1. So now my x is 32 and my a is 1. So now I can say that equals 32 minus 1, which is my x minus a, times this. So x is 32 to the n minus 1, which would be 19, plus a is 1 times x, which is 32, times n minus 2. 20 minus 2 is 18. Okay, and we're just going to keep going out, plus dot, 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 dot. Now let me move this over. I ran out of room. Let me move this all over here. Okay, so now I have that, and I keep going, and then all the way out to, and then we're finally going to get plus 32. Where'd that 32 come from? It's right here. A squared is 1. It's going to come all the way out to x to the a, I'm sorry, a to the power, some power, which is 1 to any power is just still going to be 1, times x, which is our 32, all the way down to 20 minus 19, which is 32 to the first power, which would give us 32, plus our last term, a, which is 1 to the n minus 1, which is 1. Okay, so we get 32 to the 19 plus 32 to the 18 plus 32 to the 17, 16, 15, 14, 13, all the way out to 32 to the first power plus a 1 at the end. Okay, so this tells us right here that therefore 32 minus 1 is a factor as well. Okay, so now we're going to deal with a much smaller number that we can actually calculate, because I showed you on the calculator here, the last problem, it was a really big number, 30 decimal places. It was a big number. But now we're going to say, well, if this is x and this is a, then 8 cubed minus 1 is going to equal 8 minus 1, x minus a, times 8 squared plus 8 to the first power plus 8 to the 0 power, which is 0, and then all the way out to a to the 1, which is 1. So it's going to just be this number, the base, to the power that we one less than the power we started with, and then you just decrease a power at a time all the way down until you get to the base to the power of 1, and then you add 1 at the end. That's basically what that formula is. So that is going to equal 7 times 8 times 8 is 64 plus 8 plus 1. So this is going to equal 7 times, well, 64 plus 8 plus 1 is 64 plus 8 is 72 plus 1 is 73. So I get 7 times 73, and 7 times 3 is 21. 7 times 7 is 49 plus 2 is 51, 511. Okay, so 8 cubed minus 1 is 7 times 73. So if I check that with my calculator, 8 to the third power minus 1 equals 511. 7 times 73 equals 511. All right, so we just took a really big number, 511, and found two factors of it by using this formula, 7 and 73. All right, page 3 brings us to the end of lesson 7. Review the lesson summary and go to your problem set.